Welcome to Spring LIB.
So, in a precipitation reactions, spectator ions are those ions that remains in both sides of the chemical reaction equation. So, for example, if we take a reaction of lead nitrate in aqueous condition reacting with the potassium iodide, and in product we will have lead iodide, which is an insoluble ionic compound. That means it will be in solid form, and we'll have KNO3, which will be in aqueous form. So since lead nitrate is in the solid form, that means the lead nitrate will be precipitated as a solid, and that's why it is called a precipitation reaction. So now if we write down the total ionic equation for this, we will have all the aqueous substances will be dissociated into ions. That means we'll have Pb2 plus in aqueous, NO3 minus, we have 2NO3 minus as aqueous, and then we have K plus also as aqueous, and I minus as aqueous, and in product we will have, since PbA2 is a solid, it will not be dissociated into its ions, and we have K plus as aqueous plus NO3 minus as aqueous. So now from here we can see that, so the spectator ions are those ions which remains in both sides of the reaction equation. From here we can see that nitrate is present in this side and in this side, and this K plus or potassium is present in both sides, but not Pb2 plus is present as ionic form in both sides, and not the iodide. So that means here nitrate and the potassium, these two are our spectator ions here. So in a precipitation reaction, the ions that cannot form an insoluble ionic compound uh, in any kind of reaction, those ions will be basically the spectator ions. So for example, here we have nitrate. So all compounds of nitrates are soluble in aqueous solution. That means nitrate will never form an insoluble compound like this, and it will always remain as ion in both side of the reaction. So s- that so these kinds of ion like nitrate, which will always remain in ionic form or ionic condition in the aqueous solution, these are actually always be remain as spectator ion in any kind of precipitation reaction. So from the given choices, we have to find out which ions will always remain soluble in aqueous solution and will never form an insoluble ionic compound, and those choices will be our spectator ions, which will be always spectator ion in a precipitation reaction. So we start with the first one here. We have chloride. So we have to find out if chloride can form an insoluble ionic compound or not. If it cannot form an insoluble ionic compound, that means it will always be a spectator ion. But if it can form at least one insoluble ionic compound, that means it will not be a spectator ion always. So if you look at the solubility chart here, you can see that for chloride, we can see that normally all chlorides are soluble, but there are exceptions with compounds of silver, mercury, and lead of chloride will be insoluble. That means chloride can form insoluble ionic compounds, and that means chloride cannot always be a spectator ion in a precipitation reaction. Now we go to our option B, which is a nitrate, and which have already shown that nitrate is always soluble in aqueous solution. That means there is no exception. That means nitrate will always be soluble in aqueous solution, and that means it will never form an insoluble ionic compound, and that's why nitrate will be expected around always in a precipitation reaction. Now in choice C, we have NH4 plus. So if we look at the solubility chart, we can see that um, compounds of NH4 plus are always exception to the insolubility of um, these ions. That means NH4 plus ion is also soluble in aqueous solution always. That means NH4 plus will never form insoluble ionic compounds, and that means NH4 plus will always remain as a spectator ion in a precipitation reaction. Then we have sulfide ion, and if we look at the sulfide ion here, you can see that sulfide ion are usually insoluble. That means they will form insoluble ionic compounds, and that means um, it can not always be expected around. Finally, we have sulfate. So sulfate ions are normally soluble in water, but there are some exceptions. So compounds of strontium, barium, mercury, and lead will form insoluble ionic compounds with sulfate. That means sulfate will form insoluble ionic compounds sometimes, and it cannot be expected around always. So sulfate is not capable of um, being expected around always.